Hello and welcome to Livestreams. It's a Livestreams Tuesday. Welcome, welcome, welcome. We're testing that we're live. You're seeing us. Write down in the comments if you're seeing us. And we're going into intro. All right, folks, welcome to Livestreams. As always, my name is Viktor Gemov, and I'm a developer advocate here with Confluent. And it's great to be live again. And as you can see, hopefully you see and hear me very well. If you do, please let me know in the comments if you're seeing this, if you're receiving this signal from my side, because right now I don't see any activity. Hopefully I'm not talking to myself as I always do in this in this world. All right, so we're talking today about some stuff, and let me see if I can see my people. All right. At least some of the people here. Welcome to Livestream. So if you're first time here, we usually have this small game introduction. So write down where you're coming from and maybe what's in your coffee mug right now, or coffee or tea mug, or like what's you're drinking right now. As a matter of fact, I don't have a mug today, so I'm, as always, drinking some of the canned energy juices. And yeah, that would be very interesting to learn where folks are coming from. All right. As always on the live streams, our goal is to have it in a time zone that is very affordable, very inclusive. So we can have people all over the place. It is 12 o'clock here in New York. It is 9 a.m. in San Francisco. It's supposed to be somewhere around 5 p.m. It's almost 2 o'clock in London. All right, I see some of our regulars. Naveen, he said he sees me loud and clear. Let me know if everything. I'm checking if the stream goes according to plan. David from Kenya. I think David, you're the first person who joined us from Kenya. I haven't seen, at least no one publicly announced that they're coming from Kenya. Welcome, Bryce Boris from Abidjan. Where is that? Is it town or country that I don't know? And we have some very impatient people who join this and very eager to learn what we're going to do today. And we're going to do some awesome, exciting stuff. I think I was wanted to do this for a while now, and there was something happened usually, either running out of time or I have some other subject to pop up. So yeah, essentially today I want to talk about some of the interesting stuff. Before we jump into this one, so first of all, like quick announcements as always. I'm going to switch to my screen share. Kafka Summit. If you wanted to speak at the Kafka Summit, you probably already submitted some of the papers to Kafka Summit, but if you don't want to, you just need to go and register so you can be in May. You will join us, some of the speakers in the Confluent and the community, and basically like people from all over the world who join and share their knowledge about Kafka. So highly recommend to join, to register. So that's registration is open. It's free this year. So that's it's going to be cool. Now, for many program committee members, and yours truly also honored and blessed to be in a program committee. It's some hot stuff is starting, so we need to pick up some of the interesting topics from the submissions. So that's going to be interesting. Now, that's something that you folks wanna know. The topic for today. So we're going to be talking about some things that I already touched a little bit, and today we're going to be talking about a little bit more details. And I would like to show you something interesting in the world of streams, in the world of Kafka streams. As always, feel free to ask any questions. That's the purpose of this meeting or purpose of this stream is not only for me to talking, but also for me to learn what bothers you in terms of like what kind of questions you might have. Also, just to have a conversation. You know, if you might have some question, that's the right place to ask this question. It's a great place to ask this question. So yeah, that's the purpose of it. If you're watching this somehow, like you appeared on this live channel, I'm coming to do live shows, live kind of conversation, live open hour, office hours, something like that, every Tuesday on this YouTube channel. So make sure you click that subscribe button and enable notifications so you will be notified when we go and some other things. There's some questions not about Kafka streams, but would be cool if I handle about integration, Elasticsearch, and the Kafka. So maybe not today. We're not, because I already have something that I want to share, because it's a great topic. And I do think I might have some interesting content around this, and maybe some interesting demo around this. So the purpose of like the idea of the live stream is for me to not only just do whatever I want, but also do something in a time-boxed manner. So in this case, like usually we don't run over like certain time. Like in this case, like we want to have a 1 hour. But you probably, unfortunately, I don't know how to read your your YouTube ID. I don't read. I guess it's a Korean. I believe so. I don't. I just get very interesting idea that I might explore in future. So as you know, some of you might know, some of you don't. But on this live channel, we're also running some of the workshops, and previously you can find the previous workshops in our YouTube channel, in Confluent YouTube channel, youtube.com/Confluent. And those are usually running more, and they're hands-on. You can also participate, you can join. We'll see if this elastic thingy, you know, this question, I may be turning this in the workshop. I don't know. Like we'll see how it goes. I already have planned at least 2 workshops. Stay tuned for announcements. I'm not gonna reveal this secret yet, but it's gonna be awesome. A few more workshops are coming. Now, to our topic. So I'm gonna be talking about Kafka streams and interactive query. So what is interactive query? What is interactive query? So first of all, we touched this slightly little bit in the previous workshops. If you go to one of the workshops from November 17 that I use as my kind of example, that we discussed in this workshop, I use this idea of building a materialized view from Kafka topic. So we have a Kafka topic with orders, and I push some data in these orders, and after that I enable access to this state through some sort of API. Though this data, as you can see here, it will not lend any other Kafka topic because I just created this table and I didn't send this back to Kafka. So in this case, my application will become a materialized view, and my state store will include all this data. And this is usually how I can get access to this one. So in this case, from the Kafka Streams instance, I can get my store, and based from this, I can query the store because it's just a key value storage, and this thing will be available out of the from the theme. Here's the problem though with this approach. With this approach, this approach only works if there's only one instance of this application. If there's only one instance application, you go and hit this interactive query endpoint, and at this point. What's wrong with my language today? Yes, and at this point, your application will include everything. But what about if you will run this in distributed mode? We know that we can scale Kafka Streams application, and if you don't know how to scaling works, there is actually, if you haven't seen this thing before, this guy is doing his stuff. But in our YouTube channel, in a playlist, there is a I was talking about scalability of Kafka Streams and how it works with the Kubernetes example. So this is something that you want to go and revisit back. So essentially, this stuff only works if we have a one non-distributed mode. Let me show you how does it work. In this case, I will bring some of the drawing board. So we have all cool toys and cool tools in the world, so we can talk about some things. So we have this application user that usually wants to hit your application, and this is our Kafka Streams. Kafka Streams application. And essentially what we have right now, we have, it does a REST call, a REST, and it says like orders /1, okay? So it goes one request. So what Kafka Streams does, because my Kafka Streams is a part of a bigger Spring Boot. So in this case, Spring Boot handles all the REST thing. And right now, and my Kafka is over here. So my Kafka Streams works with this guy, all right? So that's like very simplified version. And this is very simplified version of this use case, where we can do, this is our orders table. And inside this Kafka Streams instance, it would be materialized inside this orders store. You've seen this here. That's what essentially this piece of code does. So I used more energy to draw this on the board than I actually code this. So that's very simple to do, like build materialized view is very simple to do with Kafka Streams. Now, so what's going to be happening if we start another instance of this application? So another instance of this application. We will have another store, but in this case, the stores would be distributed across here. So because number of partitions in this topic, by default, I guess it's 6. So we will have each store per partition. again, I'm not gonna repeat this over. That's something that I already shared in the previous live streams. You go watch this. That was pretty cool. Now, so in order to this guy, when this store will be migrated with the order one on another instance of application, this guy needs to know address. This guy needs to know and also go and hit here, right? Hit this instance, which creates some of the problems. You cannot put the, you need to know the address of this application, or this application might not be exposing this address. So that's why interactive queries and provides certain Kafka Streams provides certain APIs that allow you to work around this one. And with the Kafka, with interactive queries, you not only will be able to query local state, that what we essentially did here with this Kafka Streams.store method, but also with something that I will show you in a bit, we will be able to communicate with remote store. And if we will return to this picture, I just created a new one. So in this case, if I will run multiple streams, and there would be user that hits some sort of API, in this case orders/1, and if we have a multiple Kafka Streams instance, and there's another instance, in this case, this particular instance of application will be able to query one of those applications and return response back. That's what we're trying to do. That's what we will try to create this. That's what we're going to be doing this today. Now, let me quickly take a look what questions that we might have. For future topic, like to see CDC features from the relational and mainframe sources. I would love to do mainframe system if I would get the access to mainframe. If you will be able to provide the mainframe for me, I would definitely do that. But for CDC system in MySQL, I think I did this. Again, if you will go and check some of the live streams, I didn't do on the Confluent channel, but I personally did this on my YouTube channel that you also can go and /YouTube. I'm always forgetting this. And if you go to my channel, you'll go these videos inside the playlist around something like videos. I will show some of the streams that I did with CDC in the past. I did testing. Yes, so I did this live stream where I talk about change data capture with MySQL and change data capture with MySQL and Debezium. So you can go and check this out if you impatient. And I will show you this one. So in my YouTube channel, I will share the link. So if you will be able to get this to the comments, I will be able to share this. But that's a CDC video that I did some time ago using Debezium. So that's go and check this out. All right, cool. So let's get back to some questions. When you want to try Excel draw, I don't know what is it. I like to use my iPad, do iPad screen sharing, and that's how I roll with drawing. So that's my go-to tool. I like to have something in my hands like a pen. I love it. So yeah, that's what we have. And we're going into in our application development. Now, so first thing is what the documentation will tell us. If you go to this interactive queries, there's a couple of things that needs to be done. And most importantly, you can read a little bit more about accessing a local store, a little bit more about the getting this stuff. But if we want to access to distributed store, so remote store from instance of different applications, where is it? Now, so there's a couple of things here. So documentation says there is no built-in RPC level. What does it mean? There's no ways, there's no built-in RPC, there's no built-in the mechanism for application to query. So you need to build this yourself. And in this case, it's a good thing and a bad thing. So good thing that you need to develop something yourself. But the good thing, you don't, there's no one is prescribing you what to use. If you want to use REST, you can use REST. If you want to use something else, and today we're going to be using something else because there are plenty examples of using REST. I want to use something that is not REST. If you go to things like Kafka streams, examples, GitHub, you can find something, come on. There's no official, yeah, I think it is. Kafka streams, examples, so word count, not much. Okay, so I will go into, just give me a quick second. I will find this right example from Confluent and Confluent GitHub. So this example is conveniently placed in Confluent /Kafka streams examples, and there would be example of interactive queries. So there's example that use this interactive queries. It provides a REST endpoint, but I don't want to use REST endpoint today. Today I'm going to be using RPC, like which real RPC, gRPC. I'm going to be using gRPC, or we're using this to communicate of our systems. Now, so we have a RPC layer. We settle on RPC. We're going to be using this gRPC. Now we need to provide the ways how the application will be discovered. And the way how it happens with the Kafka streams is by providing these application server configuration parameters. So this information will be attached to some of the metadata that instances of Kafka streams application will exchange in order to these services will communicate. And also it will allow to get access to some remote stores from this application. And so on the RPC level, we'll be able to do a discovery. So that's picture how they do it. That's essentially, we will put this information about application host, and now it would be attached to all this metadata. So the next time when I do this step of call, this user needs to only call one instance of this application, only this one. Okay, so I'm sorry, let's do this one. We'll do this, we will call this, and if we'll do something like orders and 2, in this case, maybe the state store will not be available in this instance, so in this case, it will go to this, to another instance. And the cool thing is that the Kafka Streams interactive query service provides the ways how you can do discovery. So essentially, for your application call, there would be at max, only 2 calls. So in this case, it will call this one, and from here, let's call it like a jump server, jump instance. From here, you will be able to call directly, because this application would know where this data is stored. And I'll show you how you can do this. Before I go into here, let's see if I have some cool questions. Question, is it possible to change the data stored in a topic? No, data in the topic stored in a mutable log, and this data will not be changed without going directly in fiddling. Think about this as you have your log statement that comes from your application, and each line of this log is immutable. So only reason why you want to change this is probably you're trying to like hide some of the activity of your application, some of the maybe malicious activity, and they want to change it. So there's a couple of ways how you can modify this. There is an approach that involves tombstones. Essentially, you submit the data for with particular key that you want to destroy or you want to delete with null value. So in this case, it will create a tombstone, and over the time there would be a procedure of checking the if we're talking about compacted topic. If we're talking about a regular topic, the only way how you can remove data from the topic is a retention, changing the retention of the topic, and after that, data will be removed from here. Is Confluent have Cassandra source connector for Kafka Connect? That's a very good question, my friend. And there's a very easy way how you can learn this. And you can go to confluent.io/hub, which is Kafka Connect hub. All connectors, or like a majority of connectors, are here. So if I'll do Cassandra, so there's a there's a connector from community, Kafka Connect Cassandra. Let's take a look. And it comes from, hey, it comes from Confluent. Yes, we do have. And in this case, it will include, let's see, use to move messages into, is it source or sync connector? Let's see. Kafka Connect, and it uses what? It's a sync connector. So sync connector, it can dump data out of Cassandra, out of Kafka into Cassandra. So that's one. And the second one is from, I believe it's from DataStax, Cassandra. And it's also sync connector. So in this case, it's dumps data from Kafka into Cassandra. There is a, I might be mistaken, but if I do Debezium, Cassandra, the Debezium should be able to have a connector for Cassandra as well. So there is a connector for Cassandra that can do CDC. So in case if you need to read something from the Cassandra, you can use this to read data into Kafka. And for the rest, you should be able to use either DataStax connector or Confluent connector. So yeah, so in this case, it's going to be two connectors that you can use. I hope that was helpful. Okay. So, okay, I think there's some of the follow-up question that I didn't. How you work with Kafka not from Java? How we can use Kafka REST Proxy? How we build event-oriented application? That's not very specific questions, my friend Andrew. Andrew, those are not super specific questions. However, it's no time for despair. Essentially, if you go into this repository around Confluent Inc. /examples, you can find this folder with the clients. And there are examples how you can start up your application. My dear helpers will post this link in the chat in a few seconds. So this thing has examples or all possible languages that you want to use. You want to use a Node, not Java. Go, Ruby, Kafka Cat, which is a command line tool that allows you to integrate with this. For the REST proxy, yes, you can use REST proxy here. So if you go here and say REST proxy, and you can go with application development. So in here, there would be a whole section in application development that uses REST proxy and explains the protocol, what you can submit, how you can read the results, how you can configure producer and consumer, all good stuff. So you will be able to do this from the REST proxy. Let's see if I check something. Yeah, so yes, we're gonna be looking at the gRPC in a few seconds here. So does the concept work if I scale my application? So yes, in this case, if you scale your application, this still will work. I will show you how we can run this in a multiple minutes, in a few minutes. How you know which broker is controller? Any commands to check. So essentially, this information about the brokers, broker is a controller, is available through some sort of metadata. Let's Google it. Let's take a look. Kafka metrics controller. Let's take a look. So there is a keep, as always. There is a keep for some of the metrics, and Kafka controller state. So I believe if you will get the information about the controller, you should be able to get information about who's current broker somehow. Like you should be able to get this information out. I don't have this information like on top of my head, and I don't want to spend the time to just like Googling stuff. But yeah, that's you should be able to learn which broker is a controller. Also, I'm thinking if you can get this information from Zookeeper as well. I'm trying to not rely on Zookeeper as much as possible. Let's see what kind of information admin API will give us. We'll just do Kafka admin API. Let's see from the code if I have a Kafka admin access to. Do I have it? No, I don't have it. For an admin, let's see comment. Exception. Timeout exception. No exception controller. Let's see what kind of metadata is available if I can get the cluster info, like something like cluster info or something like that. There should be something around admin client, describe config, describe cluster. So describe cluster result will give us so essentially when you do admin API, you can get describe cluster, and from describe cluster there's a method called controller. So essentially you do something like let's do this one. So something like this. Kafka controller. Public void get controller. In this case, admin client. From admin client, you should be able to do something like this: client dot get cluster, describe cluster, and I can get a controller ID. Let's see, what is that? Kafka future string. So controller ID, you will get, what's the documentation said? Returns a future that controller ID. So in this case, you would know which broker ID Can you do something like client, describe cluster, cluster ID, nodes, and for each node, this future, I'll just do get, and because it's a for each new consumer node, and from the node, you can get some of the information. Let's see. Port, where's the ID? This is string ID. And basically, can you do something like, you get the list of nodes in this case, and you can get some additional information based on particular, string ID. That's something that just like came up in my in my mind that how I would do this. So essentially, you want to use a describe cluster, and you will get not cluster ID, controller ID. I'm sorry, controller. Oh, okay. So in this case, it would be even simpler because I just do client. I'm sorry, I did use different describe cluster. Get controller, that's going to be node. I was going to get, and after that, I will get a port, and I get the host. So you will be able to do something like this. So that's the beauty. That's the beauty of live streams. If I don't know something, I here to figure out together with you. All right, cool. So let's switch it back. All right. So if there are any other questions, okay. So I have one success example only with default JSON body working with ROC. Like that. With another JSON, I have an error. So I think that would be great a place where I can plug some Confluent community Slack. You can go and ask the questions there. If you go there and you can find some of the useful information, or you can ask people. I can provide some additional examples. All right. Yeah, of course, of course. So yeah, Andrew, I highly recommend you to check this out, the Slack, and in this case, you will be able to provide more details, and the people will. If you don't know how to find the Slack, DM me in Twitter. It's easy. How you can find my Twitter? It's over here. It's over here on the screen. Just tweet me. All right. Cool. All right. So let's get back to our application. I want to show you something before we depart. So as always, source code will be stored inside our Livestreams repository in the demo scene. So if we'll do a demo scene, that's a repository that I'm talking about. It's also on Confluent GitHub. And Livestreams, all Livestreams go in here. So the particular date, and you can find this here. Now, today, I already wrote a small application that I will share with you. So a couple things that I need to do before we proceed. So my documentation, if I go to Kafka Streams Interactive Queries, says I need to provide this application server configuration setting to Kafka Streams in order to enable this feature. So in this case, what I do, I'm using Spring, and I use the Spring in the many examples in this channel. A reason for that, there's no reason, like specific reason for that, other than productivity. I don't want to start over. I don't want to implement certain things from scratch because they might be available in Spring. So that's why I'm using this. So in this particular case, let me hide this one. So in this particular case, I'm using this. The ways how I can change the configuration parameters. I'm heavily relying on properties, application.properties. So that's why I want to have this as simple as possible for me. So my properties comes from application.properties. Now, and I need to provide this thing. So why I'm doing this in this fashion? Because I want to inject a port and server for my gRPC server. Kafka Streams doesn't know anything about REST, doesn't know anything about gRPC, but my application does. So in this case, I'm using this Spring starter for gRPC, and it actually comes with some of the cool integrations. For example, I would know if I start gRPC server, it will actually provide me with the actual port. I will show how it runs in distributed fashion. Next thing is that same Kafka Streams application. It uses table, our materialized view, and I slightly modified my application producer. So in this case, I'm using this fantastic library called Java Faker that can generate some of the random data for me. This Java Faker fella includes some of the e-commerce information. In this case, I'm just using some of the random number to generate a order ID. And this order number will be produced in the Kafka topic. Hey, there's some of the reactive code here. So it will issue the message every half a second. And it will generate some of the random ID. And after that, it will dump it into Kafka topic. And now, it's still the REST interactive query service. I'm not going to use this. It's just there because it's there. Now, next thing is that we need to have our service defined. And there's a couple things that we need to know about this. So first thing is that our definition of our service will be stored in this protobuf file. So in this protobuf file, apart from the definition of the service, we do have some additional information. We will talk about this in a second. If I will check documentation, some of the things that I need to know from this additional metadata is where data for particular store, which instance of application owns it. So one of the things that Kafka Streams provides for this is methods for discovery, all this kind of thing. So it has methods about metadata, about like what kind of key will be stored in what store and things like that. I can get metadata saying if I get the data for a particular key, I know which store will hold it. So in this case, I will be able to locate this store. So in this case, metadata for store name and key, so I will be able to locate this. Those things will be empty if application server will not be configured here. So in this case, metadata will not be populated with this additional information. So let's take a look how I am doing this in this particular application. So in my I do have the metadata service that will get instance of my Kafka Streams application, and from that metadata service, I can get all possible information. This actually comes from the example that we have in documentation. This metadata service wrapper it just simply allows me to do like a simple things with the objects of my own. So in this particular case, my host info is something that will be generated from gRPC data. So I want to, the serialization will be handled for me by gRPC, and all this stuff would be auto-generated for me. Now, next thing is that we have this metadata service. We will be able to introspect Kafka Streams application whenever someone calls this service. And now I need to have actual RPC layer. Again, reason why I'm using gRPC because I don't want to write my own code myself. I don't want to write the serialization myself. I don't want to write my objects. You can say, but like in REST, you can just define Java beans and the serialization will be happen by framework. Yeah, I don't want to do that either because I just want to have everything generated for me. So in this particular case, I defined a set of interfaces, set of the functions that will be available to my application. So in this particular case, there's a metadata store and get all metadata, and there will be method to get particular order. That's what I need to do from my business logic perspective. Rest of the stuff is it's a service data that will be available for other applications. Now, the next thing, and now I'm defining some of the messages. So in this case, it's a host info that will include information about where the instance of this instance of Kafka Streams application will include this information about what kind of stores this particular system has. And there's some of the things that gRPC operates on top of it. So if I want to have a get order, I will get some order response, and order response will include just items from this particular order. And it will be much more cleaner whenever we will be running this. You will understand what is going on. So in this particular case, shall we go cloud or shall we do local? Because I haven't this, you see, it's totally unprepared, but we definitely can go, we can go cloud if you'd like to see. Probably, yeah, let's do cloud. Let's do, no, we'll do cloud next time. So let's do this local real quick because I want to show you something. So we do have going into right place, live streams. Just do January. Like I said, it will be available after live stream. I will post this. If you watch this in the recording, you will be able. You already have it. You already have it in GitHub. Now, where I am, I'm going into orders view and go into the orders view. I'll just do CNFL, a local Kafka, Kafka start. So I'll just start the local Kafka, local services. Kafka start. So it will start my Kafka server. Now, the next thing is that I'm going to be using here is, let's do this one. So you will be able to see everything, and I will be commenting this one. Now, this, just do gm and something with so because I'm running all this stuff on my laptop, there would be port conflicts and things like that. So that's why I need to redefine this. And the cool thing about Spring Boot, I can redefine all the properties that are assigned here from the command line. Plus, because it's my Spring Boot application, in this case, I can use the Spring Boot tools. And I should be able to do stuff like this. So it will up and running. Some of the things that we will be able to see here. Something gRPC. gRPC server started, listening port 6565. So all good and nice and cool. If I'll just do Kafka topics. Let's do localhost 1990 port topic list. That's my topic that was created that will include some of the information about orders. And there's some data that Kafka Streams will create. It's a materialized view for rebalancing or resynchronization of my application. Now, how I can get access to this stuff here? So I would use the small application. So let's see, my application failed for some reason. It's called, I'm trying to use this small app called BloomRPC that allows me to interact with the gRPC server. Where is it? Quit. Let me see. Let me restart this. All right. So in this case, I need to get access to schema. Let me do this a little quick. Input this one. And I'll go to projects, Confluent, demo scene, and there would be Livestreams, and orders view, and build main proto. Okay, cool. Getting back. So I just imported my protobuf file here into this tool, and I also showing this is my gRPC host. Now let's do this one. So if I will do this request get all metadata, and I call it. So what it will gives me, I was wondering if I can make it bigger. I cannot. So yeah, sorry folks if you will not be able to see this, but like what I do have here is a response from my RPC server. This is from my Kafka Streams application that wrap inside the gRPC, and it has that store name field that includes all the stores that come in from this application. So if I go ahead and want to get some of the where's the get all metadata, this is orders store. This is where I need to query this. So in this case, I'm going into, say, order store and say number 42. So what it will give me, number 42 heavy duty paper computer. So that's my order number 42. And as you can see here, when I'm hitting this, it will hit only particular instance. So what's going to happen if I start another instance of this application? So in this case, I will just go gm boot run, and in this case, I will be using different port. So I will be using different REST port, and I won't be using different gRPC port. So when I do this, when I run this, watch here. So it will change from running to rebalancing because new instance of application will join this Kafka Streams instance. Now, as you can see, rebalancing into running. Now, active task 1, 2, 0, 1, and 2, and this will be using 3, 4, 5. So the load was balanced, and when I will try to hit now my get metadata for store, get all metadata. It was previous response. If I hit this one more time, now Kafka Streams has this information about that other application just joined it. Other application joined it, and we have this 2 instances of this application running. Now, this is where the things get interesting. So let's try to get, say, get metadata for store and key. So we want to know which instance of my application, will actually holds my heavy-duty paper computer. So in this case, I do have this method called get metadata for store and key. So I call it. As you can see, it's actually migrated. So this store that stores information about this heavy-duty paper computer was migrated to another instance. So that's why if I would use like previous approach of my application when I showed this in the very beginning, I wouldn't be able to do things like this. No, that's not supposed to happen. It's supposed to be order store 42. I restarted this application. What's happened? Let's see. Get all metadata for store. Well, we had this for 42, 65. Did it? Yeah, probably did rewrite this. So because I'm using the I'm using this randomly generated. So it's not paper computer anymore because I'm using this randomly generated keys. Next time I should probably just order this, load this some of the things that we can have a reproducible. But in this case, it was just like rewrite this. And because this information is stored on the different instance, but I'm hitting the instance number 1, I still getting result. And this is because I'm talking about get order. So in the method of get order, what is happening here, from the request, I am getting a key that I'm interested in. Next thing, I'm getting information about metadata of this. So I'm also using this metadata service internally to get information for particular key and particular store. So cool thing that here is not going to happen any network calls because Kafka Streams already instance of application already has this information. We don't need to go and check this every time. This information will be automatically updated for you every time when the rebalancing will happen. So when these things will be, the Kafka Streams instance will be rebalanced together with some of the additional information about this metadata will be sent. So this information, you don't need to worry about consistency of this data. This data would be always up to date. And this is where like a cool stuff is happening. So inside my this call, I'm actually proxying this call. Now I know which particular host includes this information that I'm interested in. So if I would have a third instance of this application and this particular host will not have this information, I know how to get this metadata information I'm getting from Kafka Streams. And after that, I just do simple call. And after that, I'm getting this result back. And that's pretty much it. So now I made my small application that essentially uses this materialized view option. So I'm getting this materialized view data, getting this orders data, turn this into materialized view, and after that I turn this application in distributed database. So one thing that I need to expose this is one of the host information that I can put this behind the load balancer, and users will be able to hit this request, hit this endpoint, and after that they will be able to get the result back. So that's very simple and very like simplified version of this. Write down the comments if you like this stuff, if you're excited about these things, and if you liked what you just saw. Next time we're trying to like take this deploy into. What we do it here? We deploy things to Kubernetes. Probably we'll deploy this thing into Kubernetes and see how we can scale this in the Kubernetes and still will be able to hit this API through Kubernetes. That would be a very, very interesting thing, at least for me. That's how it started. I found something interesting and something fascinating, and I wanted to share with you folks. All right, so let me quickly check the comments before I will part for today. Is it true that gRPC faster, better than REST? So I would say it's define faster. Define what you mean by that. gRPC provides a more richer semantics how we can build your applications. gRPC based on HTTP2 protocol, which is binary comparing to HTTP 1.1 protocol, which is a text-based basically protocol. There's some additional semantics built in HTTP2 protocol that gRPC uses. For example, you can easily do like a bidirectional streaming type of stuff. We're not using it here, but you will be able to use this with gRPC. So I didn't do any particular benchmark myself, but maybe there's some use cases where one will be faster than another, but it's not about speed. It's about convenience and about using more richer semantics on top of this. Plus, when you're running stuff, over years, we develop RPCs on top of HTTP. We handle all this kind of stuff around the serialization, objects into JSON and back and forth. Not super convenient. These things are baked into gRPC. In the future episodes, like a friend of mine from other live streams, he loves this kind of stuff, and he actually can show me how we can use different framework to have a multiplexed version of this application that also will be served through gRPC and also will be served through the REST. We'll see how this will go. Does anyone know what plugins allow for interactive bash history in a host iTerm? Yes, that's thing called where's my browser? My browser's stuck. So if you go here, it's called FZF ZSH. It's called FZF tool. It's the pager, fuzzy command line, fuzzy finder, and it has integration with ZSH. So if you want to try this out, check this out. It is pretty awesome. Can you explain about consumer ID and group ID? Yes, I can, but not today. Stick with me for the next session, maybe next week, where I will be talking about this because it's a little bit late in the game. I don't know about gRPC especially. BloomRPC is similar to Postman. Yes, BloomRPC is very similar to Postman, and even like a look and feel also have a similar idea. Based on gRPC protofile, this thing will be able to interrogate your service. Also, do you use protobuf schema instead of JSON Avro check response visually on BloomRPC? So BloomRPC uses a response that comes as a JSON payload, and from my proto file, it knows how to deserialize it, and it just simply uses JSON as the way how you can represent this object. So it's also built in the protobuf. It's nothing to do with the way how I use it. If you're interested in using like Avro versus protobuf, I do have a Kafka tutorial for that. If you go to Kafka tutorials, which is the website that me and my team developed about Kafka tutorials. There is a tutorial for converting stream in serialization format, and you're interested in Kafka Streams version. Inside the Kafka Streams version, you will be able to learn how you can work with the protobuf and Avro in the same code base and how you can turn one another. So this is a very good example. Highly recommend to check this out. That would be a very good one. Okay, so some of the Kafka related, Spring Kafka related question. What's your view on Spring Cloud Stream Binder for Kafka versus Spring Kafka? I love it. I use it, and I already have some examples on Spring Cloud Stream. It's also in the repository of demo scenes. You can find the example on this one. Write down in the comments if it's something that you feel that would be interesting to talk about this on this channel. I will definitely do, and we can chat about this. What's the basic price I need to pay to use Confluent server? This is a very good question that unfortunately I'm not the right person to answer this question because I'm not in the sales job. So the best way is to reach out to our sales department. Just write to like sales@confluent.io and you will get this response. Usually it comes with the size of the cluster, how many nodes you want to have, and things like that. If you want to have a same Confluent server functionality, but with managed service, we have all the prices available in Confluent Cloud. If you go to Confluent Cloud, you will get all the prices and the same functionality of Confluent server you will get there. All right, cool. All right, so it's great to, it was great to have every one of you today on a live stream. This is a quick reminder so that my name is Viktor Gamov. I work as a developer advocate. Give me solid. Hit that like button. Subscribe to this YouTube channel. Enable this notification. Every Tuesday, I'm going live in this channel talking about stuff that is important to you. Write into my Twitter DM if you have some questions, you want these questions to be discussed during this live stream. And as always, have a nice day.